We have two learning targets here in section 4.3. We're going to identify congruent figures and their corresponding parts, and we're going to use the definition of congruence, which this book and most books call CPCTC. And I'll let you know what all that stands for here in just a couple minutes. So, congruent figures. Now we know what congruent segments are. They're segments with the same measure. They're the exact same size. Congruent angles. Angles with the same measure. They're the exact same size. Guess what congruent triangles will be? The exact same size. Okay? So, let's see. Let's first talk about corresponding. We're going to get to the exact same size. But let's talk about corresponding. We've had corresponding before. When we have two lines and a transversal, we called angle 1 and angle 2 corresponding, angle 3 and angle 4 corresponding, because they were in the same position relative to the transversal and then the given line. Well, it works the same way in figures. Okay? When we talk about corresponding angles, we're talking about the angles that are in the same position in each triangle. For instance, angle A here and angle X here are in the same position, are they not? So they're called corresponding angles. Let me see, did I do this? In fact, it works this way. See how angle X and angle A are in the same spot? So they're corresponding. So identify the corresponding angles. Angle A and angle X. Well, what does angle B correspond to? Angle Y. They're in the exact same position, aren't they? So angle B and angle Y. And even if you don't understand anything that we've talked about so far, what's the only pair of angles left? So it's got to be C matches up with Z, doesn't it? It's got to be. So angle C and angle Z. Then we identify the corresponding sides. Well, corresponding, same position. So segment AB, that's a side, corresponds to which segment? XY. So segment AB and segment XY. What segment BC correspond to? Segment YZ. And what does segment AC correspond to? Segment XZ. Now, notice with these two triangles, they are the exact same size, exact same shape as well. That's another requirement. Exact same size, exact same shape. They're going to be what we call congruent. Okay? That's what has to happen. Notice something else. These corresponding parts that we've listed, what's true about angle A and angle X besides the fact they correspond? They have the same measure. They're congruent. Is the same thing true about angle B and angle Y? Angle C and angle Z? Then look at the sides. What's true about segment AB and segment XY? They're the same. They're congruent. BC and YX, congruent. AC and XZ, congruent. Okay? Now, two geometric figures. This is an informal definition of congruent. Two geometric figures have exactly the same shape and size. If they have the exact same shape and size, then they are congruent. Okay? So, these weird looking, I don't know if they're fish or disembodied heads, figures 1, 2, and 3 are congruent to each other. And then if we look over here at 4, 5, and 6, they're not. They're the same shape, but they're not the same size. Both things have to happen for the figures to be congruent. They have to be the exact same shape and the exact same size. Now, if we look at these are, actually, I don't want you to see all that. These are congruent triangles. Okay? And let me show you how come. Now, our Kentucky standards are all about calling things rigid motions. So when I drag this thing up here and show you that version 2 of triangle DEF and version 1 of triangle DEF are the exact same shape and size, our Kentucky standards call that using rigid motions. Rigid meaning nothing changes size. Okay? If I drag this over here and I turn it, no, not that one. Let's try this again. Put this one back where it was, which is a lot like that. Take this one. Now, I'm calling that good. All right. We can see that the two triangles are congruent. They're the exact same size, the exact same shape. And the reason I made another triangle with the D, E, and the F on the inside, see how we can get the corresponding parts? As it's written originally, I'm going to regret moving that, but as it's drawn originally, it may be kind of difficult to see that angle D matches up with angle T, because it's a lot harder to see they're in the same position, isn't it? Because the triangles are not oriented the same way. If I copied that one, when I made the copy over here for figure 2, I turned it on purpose to make it more difficult for you to see what corresponds to what. But you've got to be able, because you're not going to be able to do this on your own paper, okay? You got to be able to visualize, okay, if I took one of them and turn it a little bit and move it over, it becomes the other one. So we can see then that D and T correspond as angles, E and R correspond as angles, F and S correspond as angles, then segment DE with segment TR, segment EF with segment RS, and segment DE with segment TS, and all the corresponding parts are congruent to each other, aren't they? Every pair of corresponding angles is congruent. Every pair of corresponding parts is congruent. I hope I'm kind of beating this to death, because I want you to understand that corresponding parts are congruent. And I'm saying parts because otherwise I have to say corresponding angles are congruent and corresponding sides are congruent. It's faster to say corresponding parts are congruent. You with me? All right. Now, the formal definition. Two polygons are congruent if and only if their corresponding parts are congruent. So back to here, if I tell you ahead of time that triangle DEF is congruent to triangle TRS, then you conclude, oh, all 6 pairs of corresponding parts are congruent. Aren't there 6 pairs of corresponding parts? 3 pairs of corresponding angles, 3 pairs of corresponding sides. All 6 pairs of corresponding parts are congruent. On the other hand, if I tell you that all 6 pairs of corresponding parts are congruent, you're supposed to conclude, oh, that means the 2 triangles are congruent. Okay? So you can't have one without the other. If the triangles are congruent, all 6 pairs of corresponding parts are congruent. If all 6 pairs of corresponding parts are congruent, the triangles are congruent. All right, that's what this is saying. 2 polygons are congruent if and only if their corresponding parts are congruent. Now, this right here is called a congruent statement, and it's a big deal because you must write the congruent statement correctly. You must write it so that the corresponding parts are lined up. So here's how you do it. Notice that angle A and angle H in their figure are congruent to each other. So when they write angle A first to name that triangle, they must also write angle H first to name the second triangle. Put A first, you put the angle it corresponds to first. Then they put B second. Well, look here. Angle B is congruent to angle J. So if B is written down second, the angle it's congruent to has to be written down second. And then, see how I'm color coding this? Angle C is congruent to angle K. Angle C is written last. The angle it's congruent to has to be written last. Okay? You with me? Now, here's the cool thing about it. Once I have this, I don't even need the figure anymore. Just by writing the congruent statement correctly, I can tell what corresponds to what. Okay? Here's what I'm talking about. Use the definition of congruence. Anybody guessing what CPCTC stands for yet? Okay, I'll give you another minute. Write this down. Write this example down. Corresponding what? Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Shorthand for definition of congruence. Okay? All right, write this example down. We're given that triangle RST is congruent to triangle XYZ. We can conclude 6 different things by using CPCTC. The definition of congruence says that if the triangles are congruent, then all 6 pairs of corresponding parts are congruent. So the first thing we can conclude, well, one of the things we can conclude is that since R is written first in that triangle and X is written first in that triangle, they are corresponding, and corresponding parts of congruent triangles are congruent. So angle R is congruent to angle X. What's something else we can conclude? Angle S is congruent to angle Y. What's the last pair of angles we conclude? Angle T is congruent to angle Z. All right, we're halfway done. We haven't talked about sides yet, but look, our congruent statement. This is called a congruence statement. Okay? Our congruent statement gives us the sides matched up too. Segment RS is the first segment listed in that triangle. What's the first segment listed in the other one? So they're corresponding sides. So segment RS is congruent to segment XY. And then look, segment ST is the next one listed. What's the next one listed in the other triangle? So they're congruent. Now, there's one I haven't mentioned yet in the first triangle. What segment have I not mentioned yet? TR or RT. So what must it be congruent to? ZX or XZ. So, without a figure, just by knowing the congruent statement, we can conclude all 6 of those things. Okay? Questions? All right. You know what this is so far? An exercise in paying attention. Not you paying attention to me. You paying attention to how things are written. It's all about the notation. Okay? So, here's the thing you got to be able to do too. Let's pretend that we didn't know that, but that we saw this. So let's pretend we were given all of this. What would we conclude? Well, first we'd count, and we'd see that we have 6 pairs of corresponding parts that are congruent. So we know we have congruent triangles. We just have to match them up correctly. So our conclusion would be triangle, and then I get to name the one with these 3 letters any way I want. I'm going to change it up. I'm going to call it STR. It's congruent to triangle. Now, since I wrote S first, what do I have to write first from the other triangle? And then T was next, so next I put, and last I put. Now, the order is very important. and I didn't write the same thing, but it's okay. Can you tell me why it's okay? Because the corresponding parts still match up. Okay? S still matches with Y, T with Z, R with X. Segment ST still matches segment YZ. Segment TR still matches segment ZX. Segment SR still matches segment YX. They still match up. Okay? So, there is more than one correct congruent statement you can write, but it doesn't mean you can write it any order you want. Tell me if this next order is okay or not. Is that one okay? No, I don't have everything matched up right anymore, do I? So, no. That's not the right way. You got to match up the corresponding parts. Have I beat that to death yet? Not yet. Okay, good. I need to do it some more. Let's do a few from your assignment. Show that polygons are congruent by identifying all congruent corresponding parts. Then write a congruence statement. Let's do number 2 because it's a little bit longer. Then I'll let you do number 1. Okay? So number 2. Let's start off by listing the corresponding angles. Angle A corresponds to and more importantly, I guess, is congruent to angle E. Angle B. Now, here we have a choice to make. Angle B is actually congruent to angle C, angle F, and angle G, isn't it? But which one from the other figure does it correspond to? So that's the angle pair I want to write down. Angle B is congruent to angle F. Angle C, again, it's actually congruent to angle B, angle F, and angle G, but which angle from the other figure does it correspond to? So angle C is congruent to angle G, and then last, angle D is congruent to angle H. Use proper notation on these. Now we need to list the sides, segments. So segment AB is congruent to segment EF. Segment BC is congruent to segment FG. Segment CD is congruent to segment GH. And segment DA is congruent to segment HE. Now, we're matching things up, but it would still be proper to call that segment AD instead of segment DA because it's the segments that are congruent. If it's easy enough to, I still like to list the D even with the H, the A with the E, even when I'm writing the segments, but I don't technically have to. Now, we haven't written a congruent statement yet. So we've done the first direction, but not the second. Now, there is no symbol for quadrilateral, like there is a symbol for triangle, right? Triangle. There isn't a symbol for quadrilateral. So let's just say A, B, C, D is congruent to, if I wrote A first, well, what's the order I have to write the second one in? E, F, G, H. Do number 1. Oh, let me remind you something here. Let's do number 1 together because there's something here that might get you. Is that really a good idea up until today? No, because there's more than one angle Z. I'm going to stick with just saying angle Z, though, because we're matching up corresponding parts. So it's, how should I say this? It's understood that this angle Z comes from this triangle and this angle Z comes from this triangle. Okay? I'm not happy with it, but I'm not going to fight the book on this. Okay? They're going to call them both angle Z most of the time, so we will too. All right? Normally, though, it's not a real good idea, is it? Because we can't tell which angle Z we're talking about. So everybody get the same three angles I did? All right.
Angle Z is congruent to angle Z.
Uh-huh.
Well, wouldn't Y be congruent to angle Z?
Now, look how it's marked.
I mean, like...
Y is congruent.
I think you're marked the other way, though.
But go by, you can't mark it another way. It's marked the way it's marked. See, do you see what's happened? This triangle didn't just get moved over here, did it? It got flipped, which you'll never tell that. Oh, now why did that move? Okay. See if you got the same segments I did. Now, I might have called it YX, you might have called it XY. That's fine. We got the same segments. All right, last, the congruent statement. So, call the triangle on the left, name it anything you want to name it. What do you want to name the one on the left? XYZ. Trent got the call there. It's congruent to triangle. Now, I have to name this. There's only one correct answer now. Now that I've named the one on the left, there's only one correct way to name the one on the right. What corresponds to X? R comes first. What corresponds to Y? S is second. Z must be last. All right. Can you figure out the corresponding parts? Do you know that the corresponding parts are congruent? Do you know that congruent triangles, we're going to have other figures too, but we're going to concentrate on triangles. Do you know that congruent triangles have the exact same shape and the exact same size? Do you know that if you're given 6 pairs of congruent parts, that you should conclude the two triangles are congruent to each other? Do you know that if you're given that two triangles are congruent to each other, you should conclude 6 pairs of congruent parts? Then you know everything you're supposed to know at this point. All right, 4 and 5. Skipping 3. 4 and 5. In the figure, triangle LMN is congruent to triangle QRS. For 4, we find X. For 5, we find Y. Now, look over here at the side with the length of X, that has the X in it, LM, 2X plus 11. Look at your congruent statement. Segment LM is the first segment written in the congruent statement. Therefore, it corresponds to and is congruent to segment QR. So mark segment LM congruent to segment QR, and now you see how to solve for X, don't you? Those two segments are congruent to each other. That means their measures are equal. That means that 2X plus 11 equals 3X minus 9. Make sense? Yes, no, maybe. Yes? So subtract 2X, add 9. I get 20. What do you get? Good. Now we're supposed to find Y. Well, let's see here. Angle M has a Y in its measure. Angle R has a Y in its measure. I hope they're congruent to each other. Are they? M was the second one written. R is the second one written. So angle M is congruent to angle R. So their measures are equal. And you might be thinking, well, I could have worked that even if you hadn't gone through this whole big spiel about congruent parts and corresponding parts of congruent triangles are congruent and all that. But look, what if they also put, I don't know, what if they did that? Now would you know what two angles to set equal to each other? Only if you have your congruent statement. Or maybe you have to figure out your own congruent statement. Maybe they give you enough information. Well, no, not yet. Let me walk that one back. You have to have the congruent statement. Okay? All right. So far, so good. Third angles theorem. This really, I think, could be called a corollary of the triangle angle sum theorem. Think about this. If two angles of one triangle are congruent to two angles of a second triangle, then the third angles of the triangles are congruent. All right, you got one angle here congruent to one angle here, a second angle congruent to a second angle. This theorem says the third angles are congruent, that angle A is congruent to angle L. Well, use the triangle angle sum theorem. All right, angles A, B, and C have to add up to 180, correct? Angles K, L, and J have to add up to 180, correct? Don't these two add up to the exact same number that those two do? So then don't the third numbers have to be the same if they're both going to give you 180? So if two angles of one triangle are congruent to two angles of another, the third angles are also congruent. Let's see, do I really want to do this right now? I don't think I do. All right. Have you seen these properties before? Reflexive, symmetric, transitive. We've done them for congruent angles. We've done them for congruent segments. Now we do them for congruent triangles. Triangle is always congruent to itself. That's the reflexive property. If I write down triangle ABC is congruent to triangle XYZ, and you write it down as triangle XYZ is congruent to triangle ABC, we've said the same thing. The symmetric property says so. And if triangle 1 is congruent to triangle 2 is congruent to triangle 3, then triangle 1 got to be congruent to triangle 3. Okay? Questions? There you are.